Hello everybody. What I want to do today is to solve the biggest problems that we have with science. Now you might think that we have science pretty much sorted out. But once you know the answer, you can lay out the problem so you'll see we really don't have it sorted out. So here's the big problem. If I look at the elements here, all I see is inert, dead mathematics. They're not really physical anythings. They use quantum behavior. But reality looks like this. DNA, only made of the elements. Now the elements we explain using physics, but physics only has the forces of the strong and weak nuclear force and electromagnetism. There's no way that those forces can produce DNA. DNA is produced by mathematics, which was looked at by an English mathematician called Hardy. And to his surprise, what he found that the genetic mathematics gave back more to mathematics than it took. This is mathematics that's doing itself. So there's a huge problem at the atomic level of how the elements, which only have positive and negative electrical charges, some spin, some quantum numbers, change into DNA. Big problem. That's a huge problem. So at the atomic level, we can't go from here to here. We'll do the genetics and the biology, but we can't say how it goes from here to here. That's at the atomic scale, atomic forces, nuclear forces. And we've got the same problem at the gravitational scale. Now you might think that gravity explains everything that happens in the solar system. It doesn't. Newton writes down the equations that shows how it behaves between two bodies and two bodies only. Einstein shows you how it can work without a physical connection in between the bodies, but it doesn't explain all the patterns that we see in the solar system. And this beautiful patterns we see in the rings of Saturn, which are a relationship between what's happening with the moons and the planet, and I get something new in between. This is harmonics. This is pure mathematics. So once again, we see at the genetic level, we need pure mathematics to explain what's happening. At the gravitational level, we need pure mathematics to see what happened. So let's give you the answer. And then we'll show you how to use the answer and how simple it makes everything. Now this is a problem in mathematics that we call an NP problem, non-deterministic polynomial problem. Now that means that if you just put it into a computer and left the computer to try and solve the problem, it would take trillions of years. But if you have patterns which can lead you to an answer, it's very easy to check the answer. So that's what you can do after watching this video. You can check everything that I'm saying, and then you can just use logic to see if it's correct. There's no new science, there's no new mathematics, it's just the way that it's all fitted together. We already have all the pieces. So let's show this problem again of if we can't go from here to here, this is the universe becoming more complex, and show you where that comes from. Now if we go back to the steam engine, physics, here we find the second law of thermodynamics. Now this says that everything always goes from order into more disorder. But what we see in reality is reality going from clouds of hydrogen in space and nothing else, changing into more order with stars and elements, which changes into even more order with solar systems and genetic systems. So that's what we've got to clear up today. How does the solar system go from simple to complex? So the first things which are made in the solar system, the stars and the elements, there's a big question mark, is how I'm getting from here to here. Simple, more complex. If I've only got physics. Now Western science has decided maybe 300 years ago that everything must be answered by physics. But as you will see, that is not true. That's never going to be true, because physics is never going to explain physical biology with animals and plants and human behaviour, or genetics. It's not going to explain what happens in the solar system. Gravity is far too simple to explain the rings of Saturn. Now, if I look at reality, what I see when I look at, say, a proton or the electron, is that I've got two answers, both of which are correct. When we say the proton is +1, that is not its electrical charge. Its electrical charge is 1.6 times 10 to the minus 19 of a coulomb. That's the physics. +1 is a mathematical number. It's its mathematical charge, and the electron's the same. So I'm using a combination of physics and mathematics. And if you look at atomic physics, all of atomic physics is explained by pure mathematics, very often written centuries ago. Now that needs an explanation. If you look at nature, you find the Fibonacci sequence, you find mathematics all over nature, plants and animals. So it's a combination of mathematics and physics. Now let's just see what that does for us and how I go into very, very complex systems like this. Now we've just begun to understand chaos and complexity, nonlinear dynamics, using this mathematics, nonlinear mathematics. It's pure mathematics. But if I now state that reality can only be described by a combination of physics and pure mathematics, I'm not breaking the laws of logic. I don't end up in contradiction. I can go from simple to complex, not just using the laws of physics, but using the laws of mathematics, so I don't contradict the second law of thermodynamics. So now I've got an answer here, is that I'm using mathematics. These are numbers, quantum numbers are just numbers, and that's the only way we can describe what happens at the quantum level. Now there's another problem with physics, is that we've got the physics of relativity and the physics of quantum physics, and we've got two different sets of physics which don't seem to fit together. But now I'm going to show you how they do fit together if I use a combination of mathematics and physics to explain reality. I can go from simple to the first two. Now notice that I get a duality. What's happening at the quantum level, the release of energy and the formation of new elements, is causing that star to hold itself in existence. It's holding the star up. What's happening at the gravitational level, the relationship between space and matter, is squeezing the elements together. So I've got a feedback system, and what's happening here is causing something to happen here, which is causing something to happen here. And there's a ratio here which balances everything, the pull and the push. That's the simplest kind of something bringing itself into existence, where here there was nothing. Something from nothing. Now we see that again, if we look at the formation of a proton, I've got two different types of quark, but I've got three quarks, and three quarks start to behave as something completely different, something completely new, a new component in the universe that was not there before. It changes into something else. Now that is the basis of all complexity theory, is that things emerge out of something that was here previously, but they change their behaviour and behave as a new component in the universe. So now I've solved my problem at the genetic level. I've got mathematics and physics giving me what's happening here. So even at the chemistry level, I find that these beautiful shapes here are described using the mathematics that was written by Évariste Galois hundreds of years ago, we call group mathematics. But now I get a description of chemistry. I've got chemistry and out of the physics. And this is static, but that goes into the dynamic cycles. We have now a relationship with energy, biology, what's happening inside a cell. But now that's okay, I'm not in contradiction, so I can start to describe the universe directly as going from very simple to more complex, and I start to make new elements, new numbers, new mathematics, which will be released, and then I can start to have solar systems, which again will find stability using mathematics and physics, and that stability will allow the evolution of chemistry and life. And that puts together what's happening with quantum mechanics and relativity. And now let's show you that because I'm not trying to squash it all into one kind of physics, that these two obey Heisenberg's uncertainty principle. Now, physics is based upon complementarity, the fact that you must always have two parts of the same thing. One must be the inverse of the other. So what happens at the quantum level, you know the quantities, they're all exactly the same, but you don't know the position and the momentum. But at the relativity level, you know the position and the momentum, you don't know the quantity. So they're inverses of each other, and these act against each other. If you don't have quantum mechanics and relativity here, you don't progress from this into new elements and stars. That's it. So this must also put together the different parts of relativity. We've got special relativity and general relativity. So let's now put that into the same pattern. Everything comes as these dualities, and it's a mathematical and a physical solution. So I'm going to see everything that happens in physics also happens in mathematics and vice versa. So in physics, we have the real parts of physics, my magnets, real elements, but the magnetic field outside doesn't have these real units. That must show up in mathematics, and it does. We've got numbers, we call imaginary numbers in mathematics, and it's a relationship between imaginary numbers, bits that don't have real units, and the real numbers that give us mathematics. You can't do mathematics without it, especially the complex mathematics, which is all described by a combination of the imaginaries and the reals. So we've got space, which we'll describe as these imaginary numbers, numbers that don't have these real units. They're always described, we call it the quantum vacuum. But there's the quantum vacuum now, the electromagnetic quantum vacuum, which gives magnetic fields and electrical fields, and then the quantum vacuum which gives the gravitational fields. So now I've got both of these and a relationship between matter giving me general relativity, but now I've included electrical magnetic fields and gravitational fields. The relationship between the real numbers of matter, my imaginary numbers, which much, much stronger fields for electromagnetic fields, are positive and negative. The quantum vacuum, the numbers which are going to give me gravitational fields and mass. So that's what gravity is, relationship between imaginary and real numbers. So here's general relativity now with electromagnetism added in. So I've got my imaginary numbers here, and I've also got energy here and matter. Now E equals mc squared. With energy here, I get lots of energy from mass. Now mass is just a relationship between matter and space, but that's the most energy, matter. Then I have light, then I have this energy, and the least energy, the energy of empty space, these values here. So a relationship between the most energy and the least energy is what gravity and mass is. So I've got E equals mc squared, a relationship between matter and light. I've got a relationship between electromagnetic numbers, quantum vacuum numbers, and matter, a relationship between matter and gravitational vacuum numbers, and I've also got a relationship between these numbers, photons, particles, and these numbers, which give me here light waves. Now, the speed of light sits here, the rate at which light is produced. Now that's always constant, so don't think of the speed as light as something moving, it's the rate at which it's produced. And you can see if you put these numbers together, they make each other denser and denser, so that concentrates space. So matter concentrates space, space concentrates matter. If I've got enough matter, I get a black hole, space changes into a sphere, and light will go around that sphere. Light is in a relationship with these numbers. So it all now fits together. Here's all the different parts of relativity, all fitting together. And what about special relativity, the relationship between time and matter and light? Well, time is just change. Now change starts back here. If I've just got two different kinds of mathematics or physics, I put them in each other's presence, they cause change. If it's making something, it's becoming more complex, we're going to say that must be time, which is positive. And all change is underpinned by the mathematics of the exponential function. Evolution, which starts with stars and elements and then moves on to solar systems, chemistry, and biology. It's becoming more and more complex. So I've got mathematics, e to the x, which underpins that. And the reason that it's e to the x is that the exponential function underpins all change, and it's its own value of change. That's what's important about the exponential function. So we must have time, which is negative, to fit my geometric pattern. So if I've got chaotic, if I'm becoming more chaotic, now this is physics, this is entropy, when this star explodes and releases those elements out, I'm becoming more and more disordered, and that's also underpinned by the same mathematics e to the x. So here is relativity, now including evolution, chemistry, biology, all the different parts of relativity, just relationships and the numbers. So again, it puts together the quantities, the space, the relationships, and the change. Now that is a description of mathematics. If you look at a definition of mathematics, that's what you find. So now you'll see that our relationship is all based upon the fact that we always start, the first thing, I have two. And space is made of particles which always come in two, which can self-annihilate, put themselves back together. 2 is the first prime number. And we've known for a long time this answer must be based on prime numbers, which sit underneath the order of the other numbers which they produce. So there's my randomness right at the beginning, the randomness of the primes leading to the order of the composites. And that will show up as a relationship between E, time, and the two parts of space and matter, the countable, light and matter, the uncountable, the quantum vacuums, the uncountable, the countable. This is the zeta function, which comes out of the prime numbers, can have a relationship with time. So there it is, all neatly put together. Now this has been peer-reviewed and peer-reviewed and peer-reviewed over the last 3 years here in Taiwan. We've got hundreds and hundreds and hundreds of examples of mathematics and physics being the same thing. The elements are numbers. They are far more mathematical than physical. And we've come up with these nice charts that show how all the parts of relativity, quantum mechanics all fit together. So it really does solve that problem. And we found a nice little algorithm based on the first two prime numbers. So again, it's a geometric model in which you can put everything. I've got two parts here which are inverses. Space, matter and light, and that gives the third component, time. Now that little algorithm, if you rearrange the standard model of particles, you can put it all into that same algorithm, and then you find you can put everything in the universe into the same little algorithm based upon the first two prime numbers, not only for the beginning, the forces which now need to be rearranged into the same algorithm, the strong, weak nuclear force, the electromagnetic force, the atomic forces, based against gravity and acceleration. And then I just have to say, well, I must use them together here. I must have the relationship between what's happening at the gravitational level and what's happening at the atomic level to move on, to get my increasing complexity. And you can put everything in the universe into the same pattern. And the whole universe itself, two different parts of physics, quantum relativity, and nonlinear mathematics, that gives me an answer to everything. So not only have I unified quantum mechanics and relativity, I've unified the different parts of relativity and evolution, and put it into a nice little chart which shows the algorithm, the two different parts of physics, with nonlinear mathematics. I then get reality in the middle, the reality which has parts which are predictable. So if I look in the solar system, I look in the little bits of ice inside here, I find that they're not predictable, they're chaotic. But the rings are not chaotic, it's all predictable. So it's a combination of both. So everything needs this dual explanation, which is finite and infinite, matter, space, predictable, unpredictable, countable, uncountable, waves, particles. So matter simply behaves as a wave to space and a particle to itself. And that answers the biggest problem in physics, the measurement problem, is that if you have a detector, it's always going to be made of matter, so you always find it's matter because matter relates to matter as a particle, matter relates to space as a wave. It has both answers at the same time. So there's an answer now which is simple. You can all go and check this. It's been checked and checked and checked here in Taiwan until everybody says, well, that's logical. And science as it stands simply can't go from here to here, never mind from elements to genetics. So this is something which anybody can test. It's only logic. So it's a video put onto the internet that all human beings can test and understand. So that really is something new. See you next time. Bye bye now.